All right, last time we started section 10.1, Conics and Calculus, and we had talked about 3 different types of conics we're going to look at. The first 2 we kind of explored in their fullness, parabolas and ellipses, and we had just started to touch on hyperbolas when we left, but I had not done a drawing. Circles are just a specified case of an ellipse. Yeah, so everything that we actually talked about with circles works, or with the ellipses works for circles. It's just a special case. And I put the homework up here, but I'm going to move it to another screen because it's in the way. Oh. Okay. Now it's on both screens. Okay, so we were on the screen for hyperbola. Let me just remind you where we were. There are 2 standard forms for a hyperbola. The basic difference has to do with whether it opens up and down or left and right. And so the transverse axis is the axis that cuts through the graph. And we see the x value first if the transverse axis is horizontal. Horizontal means that it's opening left and right. And we see the transverse axis being vertical if the y is first, right? It's positive, and this would be meaning that it's opening up and down. So a couple of pictures and just kind of identifying some of the pieces that we discussed last time. So here's that first one that's being described, opening left and right. You see a point in the middle that is the center of the image, right? So he's got symmetry all around that center point going on. Vertices are the corners that sort of feel like it would be like the vertex if you were talking about a parabola, right? Same kind of a feel to it. Foci, much like the parabola, occur inside of the curves. Okay, so these are vertices. And these are our foci. And my transverse axis cuts the graph in half, like 2 symmetrical pieces half. So let's do it like this. So the transverse axis looks something like that. And there are actually asymptotes present here that help us to draw the graph well. And there are equations on how to find them. I'll draw them in blue. They go through the center. This is a great looking picture. Lots of color. The asymptotes are really easy to find if you have a picture already started drawing too. So if you want to use formulas, go for it. But I'm going to show you how you can do it without them, kind of like I did when we talked about the ellipse. The same thing is happening. I'm not going to draw all the pieces in, but we can have it opening up and down like this. This is what happens when the transverse axis is vertical, like that.
What did you say the blue lines were?
The blue lines are asymptotes. Okay, you ready to see an example? Okay, so our example wants us to find most of the pieces I already mentioned. Find the center, foci, and vertices of the hyperbola and sketch its graph using asymptotes as an aid. So notice the directions actually don't ask you to state what the asymptotes equations are. You'll be able to do so based on the picture here in a moment, or based on formulas if you want to go back and find them in your book. But they don't ask for them directly. Okay, so here's our equation that we're working with. X minus 1 squared over 9 minus y squared over 4 equals 1. Okay, so the first thing it asked us for was the center, and that's typically speaking, at least if it's already in standard form, which this one is. And we talked last time, just to remind you too, what happens if it's not in standard form. So we have to do some steps to complete the square. It works exactly the same if it's an ellipse or a hyperbola or a parabola. They all work the same, it doesn't matter. So we're just jumping to one that's already in standard form to see the differences of what happens. What is the center of our hyperbola? Yeah, it's 1, 0. And do make sure that you're just not reading from left to right, but that you're actually looking at the value grouped with x for the x and grouped with y for the y. Here on this one, it's the same thing, but they could switch, right? So if you were looking at this one over here, notice the second equation has the y value first, but you'd still write the center as x, y with the corresponding pieces. Okay. So vertices, we talked about those last time as well. So I'm going to flip back and forth a few times over here since we broke this apart across 2 days. The vertices are found on the bottom here. Where is it? Do you see it? There we go. The vertices are A units from the center. So A is the value that comes first in either form. So this 9 right here is telling us how far away we are from the center. It's not 9 though, it's 3. So make sure you're using the square root. So this would be 3 units away from the center. So if the center is 1, 0, maybe we should pause and just ask, what's the transverse axis on this? It's a horizontal transverse axis. So since it's horizontal, the basic overall shape that it's going to be doing is it's going to be opening like this. So the reason I'm mentioning it is because wherever my center is, because this is a horizontal transverse axis, I'm changing the x value to get to, these are foci I'm pointing to right now, but to get to the vertices as well. So I'm operating on the x value. If I had a vertical transverse axis, I'd be affecting the y value and going up and down from that value instead. So this one is 3. So it's 3 away from the center. So I want 3 away from 1 in both directions. So what values will I get? Yeah, so I'll get, say that again for me, Annika. -2 and 4. And the y value stays the same. So my y value will still be 0. So take my x value, I add, all right, that's our vertices. We're going to do foci. So foci, this was the equation I was mentioning before, right here. Whoops. Right there. So the c value measures how far away we're going. So c is the a squared plus b squared. So the 9 and the b, a squared is 9 and b squared is 4. So let me just move this down. So my c squared will be 9 plus 4. And so that's 13. So what is C going to be? Radical 13. And it still measures it away from the center. Okay, so we're going from the center. So my center was 1. So we'll do plus and minus the square root of 13, and then it's 0. Okay, all good? We found all the pieces. Now we're to the sketching the graph part. And we need asymptotes to sketch it, and I haven't shown you how to find them, but you're about to see that, okay? So we're going to change this to the backdrop over here like this. And I'm going to erase my kind of image that I had going on. So let's plot the pieces that we know. We know the center, we know the vertices, we know the foci. So we'll start by plotting those pieces. Okay, so the center is 1, 0. The foci are -2, 0, and 4, 0. Those aren't foci, sorry, vertices I meant. And then my foci, moving out from there, I'll use a different color, is square root of 13. So square root of 13 is approximately what? 3.6. 3.6. So it's 0.6 a little bit further out than where the 3 already put me, right? Because my vertices were 3 away, and now I'm 3.6 away. So we're somewhere about right here. Does that seem reasonable? Okay. Now, we know what the basic overall shape is going to be, right? It's going to open the way I just drew the picture and erased it from. But we're going to do this using the asymptotes. So I'm going to use a very faint colored pen. I hope you can still see it. If you can't, let me know. Because I don't want it to distract us when we're done. But what I want to do is I want to take the a squared and the b squared underneath, and I want to draw vertical lines for a squared. I'm going to draw horizontal lines for b squared, and you'll see why. So the a squared, being 9, gave me an a value of 3, and that's what put me 3 out in each direction, and that's what gave me my vertices, here and here. Can you see those dotted lines, kinda? Okay, that's the goal. I'm hopefully going to be able to delete them at the end if I draw them long enough. And then the other one, the b squared value is 4, so b would be 2, yeah? So I'm going to go up from the axis, because that's where my foci, or my center and my, well, center, foci, and vertices all are, and down. So I have this sort of box going on. Okay? The corners of my box, right, where those dotted pinkish lines meet, are going to actually form 2 more points on each asymptote.
Could you do like a slope ratio with
Mm-hmm.
the
Yeah, same idea. Yeah. So the visual is the same either way. And I can connect these now. And I will connect them dotted because these are asymptotes. So this is my asymptote here. I've got the same thing going on the other one. And if I delete, oops, if I delete my pink lines, oh, that wasn't it. Don't want to delete those. I think I'll delete them one at a time. These are the asymptotes. And you could find the equation of these pretty easily. I mean, I know there's formulas for it, but if you wanted to find them just by hand, you've got 3 points. As Caleb mentioned, you can easily see the slope. You could easily calculate the slope. Slopes and points create lines, no problem. That's algebra stuff from eons ago. And then to draw the curve based on those asymptotes means that I'm using those vertices, and I'm getting close to my asymptotes. And we're done. Make sense? Lovely.